This is our 65th lesson on the biblical flood, and we'll be into our 16th chapter. And we're going to look at some recommendations for additional study. I just don't have the time to do the research on this and follow it up. If I get time, I'll follow some of these things up some more. Some of the things I'm going to suggest here, I believe, will link in quite clearly with my flood model. So we're going to look at this. We're going to make suggestions for additional studies to see if the Fox flood model harmonizes with more things that are discovered by scientific research. And there's new things that are some of it are cutting edge, some things that have just been discovered in the past 15 or 20 years or so. If it's sound, if my model is sound, it should harmonize with additional discoveries. And I might have to tweak it a little bit here and there, but that's the nature of scientific models as we have to tweak them from time to time. It's possible, there's a possibility there's a relationship between the epicenters of terminating earthquakes. And this is an old article, Benioff, on pages 334 and 335. And the mechanism was probably caused the flood, and I think we need to look at that more carefully. The pattern of these epicenters of earthquakes may be related to the shifting of the equator on Earth from the flood, from my flood model. Here's a quote from this article. Epicenters of the terminating earthquakes are plotted on a world map in figure 4. Now, I don't have figure 4 up here. I wasn't able to scan it and get it in. The dashed circle drawn to fit the points is very nearly a great circle, and hence defines a plane passing through the center of the Earth. Now, we're not talking about an airplane here, okay? It's a plane passing through the center of the Earth. Now, I want you to remember this. It's a great circle, nearly a great circle. The great circle route is the route at which ships and airplanes travel from one place to the other. It's a shorter distance to go north from San Francisco to go north and to get to Tokyo, Japan, than it is to go straight west. And if you get on the globe, you can see why it is. It's pretty clear it's shorter to go to Moscow if you fly from, say, Toronto, Canada, to fly over the North Pole, to fly in that direction. When I flew to Russia, I flew over Greenland, then go straight east. And it's called the Great Circle Route now. We won't go through it, but you can do a research on it and see it's a shorter distance. And the Great Circle Route is what would be found, what would happen if an object traveled around the Earth and it wasn't going around the equator and it wasn't in the ecliptic plane. So this would fit my model, this moving in these points in a great circle and the plane passing to the center of the Earth. The pole of this circle illustrated the two concentric circles on the map. We won't go into that any further. It may be a mere chance that the 6 epicenters fall so nearly on a plane. That's what it says. But these epicenters of these earthquakes are lined up. If not, then this plane may describe some fundamental shearing surface which divides the Earth into hemispheres. So he's saying there's maybe some kind of a shearing surface. Again, I think this might fit in with my model. I haven't done any of the physics on it, and my physics, mostly my graduate physics, was small particle and electrical physics, nuclear and small particle physics, semiconductors and stuff like that. The effects of the flood model postulated in this class upon the isotopic ratios on the Earth should be considered. Now, let's look at isotopes. Each element has different isotopes. And an isotope is from the isos, the first three letters, is the word same. And so what we have is we have different, well, they're called isotopes, but they would be the same element, but they'll have different number of particles in the nucleus. Well, let's illustrate it with a couple of them, two or three right quick. Some elements have more than one stable isotope. That is, it's stable if it doesn't decay by radioactive decay. For example, carbon has two stable isotopes. It has carbon 6C12. It has 6 protons in this nucleus and 12 particles in this nucleus, which means it has in the nucleus, it has 6 protons and 6 neutrons. That's a stable isotope of carbon. There's also another stable isotope, and it won't decay radioactively. 6-carbon-13 is also stable. It has 6 protons in its nucleus. That's what makes it carbon. But it has 13 particles, which means it has 6 protons in the nucleus and 7 neutrons compared to 6-carbon-12, which only has 6 neutrons in its nucleus. But both of these are still carbon because they have 6 protons in their nucleus. But both are stable. Now, 6-carbon-14 is radioactive. That's just called carbon-14. Now, what we have, the isotope of carbon at 6-carbon-13 is heavier because it has an extra neutron in the nucleus, and it's heavier than 6-carbon-12. Now, the word iso means they're from the word same, and so they're the same element. That's where that term comes in. Of course, when heavier isotope will settle to the bottom in carbon dioxide, CO2's carbon dioxide solutions. So in those solutions, the heavier one will settle to the bottom. That's the way nature works. Heavier things settle to the bottom. The same effect occurs in oxygen and other elements. Now, we'll get to those in just a moment. These different isotopes are used to determine the relative temperature of certain fossils. So when they're trying to date and look at how cold it was for a particular fossil, they'll look at the amount of oxygen or carbon or whatever it is, these elements, these isotopes in it. Now, we'll show some in just a minute, particularly oxygen. The effects of the events that brought about the flood upon these different isotopes should be considered. I believe the flood and the events that occurred in the flood would have changed the amount of these isotopes and made it look like the temperature was different in the past. They look at the amount of these isotopes, particularly oxygen and carbon, and they determine the temperature based upon this, based on the isotopes. Of course, they're using present conditions to project backwards with it. Sue, HSU, claims that comets have a different isotopic ratio of carbon than the Earth. And that's pretty reasonable, but the claim is that they do, and probably there's good evidence to support that claim. If he's correct, this method to determine the relative temperature of the fossil might be unsound. The reason being because a lot of material that came from space came in during the flood. And this material would have had a different isotopic ratio of carbon. It would have had different amounts of carbon, carbon-12 and carbon-13 than we have in the Earth normally. In all likelihood, the water vapor canopy that existed prior to the flood, we'll be looking at that in just a little bit, contain large amounts of the lighter isotope of oxygen. Now, oxygen has 2 isotopes that are stable, 8O16. 8 is the number of protons, and 16 is the number in the nucleus, and 16 is the number of particles. So it has in the nucleus has 8 protons and then 8 more neutrons. So it'll be 8 protons and 8 neutrons, making 16 particles in the nucleus. And that's the stable, it's the lighter. Then we have 8O18. So it has 8 protons, that's what makes it oxygen. And then it has 18 particles in this nucleus, meaning it has 10 neutrons plus 8 protons, making 18 in the nucleus. And that's still oxygen. They're different isotopes, but the 8O18 is heavier than 8O16. And so the heavier will settle to the bottom of the solution. But it's reasonable that the oxygen in the upper atmosphere, particularly in the water vapor, would have had more 8O16, the lighter isotope in it. And when this came out of it, it would have affected the amount of stable 8O16 in the oceans. The post-Oluvian ratio, that means after the flood, ratio of these isotopes may be considerably different than the antediluvian. Post is Latin for after, and ante is Latin for before, this before and after the flood. So this would have changed this ratio and made measurements of materials due to this ratio certainly inexact, to say the least. Farley discusses the stable isotope of helium, and we have helium normally, most helium will have, to be helium, it has to have 2 protons in its nucleus, and this is 2He3, and so it has 2 protons and 3 particles in the nucleus, meaning 2 protons, 1 neutron. That's lighter than most helium. In deep sea sediment, they find the amount of it in the deep sea sediment, and Farley claims that it comes from interplanetary dust. Now, my flood model has interplanetary dust coming into the flood, into the ocean, and all over the earth, in fact, and that would put it in the deep sea sediment. And he relates it to interplanetary dust. And that would fit in with my model quite well. Farley claims that this isotope is almost totally derived from interplanetary dust. So he is giving us evidence of large amounts of interplanetary dust that came in at some time in the sediment. Now remember, the sediment in the oceans is not very deep to begin with, indicating that it hasn't been there that long. The ratio of 2He3, that's helium that comes from interplanetary dust, to 2He4. Now, 2He3 has, both of them are helium. They have 2 protons in the nucleus. That's where the 2 comes from. And one of them has 3 particles, meaning 2 protons and 1 neutron. The other one has 4 particles. That means 2 protons, 2 neutrons. So the 2He4 here that I have a mouse on is heavier. And so 2He3 is much lighter than expected because the production of 2He4, and that's most of the helium we see is that, by both uranium and thorium as they decay in these sediments. So they don't have the right ratio. It's much higher. They have more 2He3 than they expected because the production, they claim uranium and thorium produce it. We know that they produce it. This will be alpha decay of radioactive decay. And so that would, the ratio is not right according to their models. Both uranium and thorium produce this as a result of radioactive decay. In addition, 2He3 should diffuse. It's lighter, so it should come up more readily up into the upper atmosphere because of its lower weight. And yet, there's still a bunch of it there in the. This may be further evidence of a younger Earth rather than an older Earth. An additional, it could be from the rings of Mercury, and I believe that would fit my model. A number of geologists are beginning to link glacial till. And glacial till is like gravel, and it's broken up pieces of rock, and they're linking it. And the old model said glacial till was the glaciers moving across the rocks, grinding them up and making gravel out of them. And that's entirely possible that happens, and it probably does happen in some sense. But they've also linking it with the impacts of objects from space now. And this will fit my model because the glaciers, I believe, were produced by ice coming from space, from the ice rings of the planet Mercury as it caused the flood. Overbeck has an extensive discussion of this impact hypothesis. And so he discusses it considerably in 1993. Now, extremely cold objects become brittle and will shatter easily. I was told, and I've read and done some, trying to follow up with some sources, what I consider good sources, that if you take copper wire and put it about 70 degrees below 0 Fahrenheit, that in Siberia, in place where it gets that cold, they claim that whenever the wind blows, the copper wires and the power lines will just shatter like glass. And I know that they claim that if you hit an iron tire rim and it's 70 or 80 below 0, it will probably shatter it, or it can shatter it. So objects become brittle. They can go through a ductility to brittle to the ductile ratio or point. And this is the point that they go through. So if the rock then was very cold, this ice being pretty close to absolute 0 as it comes in, and it then could shatter the rocks when they're extremely cold. Grant Young replied to this paper by Overbeck, but then they responded back. And so I have the sites here where they responded back to him. So I believe these pieces of till, they call it, it's like gravel, show evidence of being shocked, being hit by something being broken off. And it would fit my model quite well because this ice was extremely cold, making it brittle, making it shatter more easily. My contentions are easily reconciled with Overbeck's hypothesis. And we'll enter some of the objections of Young that Overbeck didn't. Beck answered most of his objections. Young states in some cases a large thickness variations can be shown to be related to contemporaneous faulting. Now, fault is where the ground shifts up or down and or moves side to side. And so this, of course, would occur during the flood if the ground is being pulled by the gravity of the planet Mercury as it moved around the Earth in its 3 to 3.5 passes around the Earth. It's my contention that the faulting, the rifting, and the volcanic activity were all contemporaneous, or they all occurred during the flood with the impact of these bolides, these objects hitting the Earth during the flood. But remember, we have craters in the Earth's crust, craters in the sediment. We have craters, and then the craters are filled with sedimentary rock, and then we have other craters above. So as the planet moved around and cratered the ground, then that crater filled up with sediment. And then it had other craters, not necessarily right above it, but in the area, in the sediment that's above, the rock that's above it. So in the flood model, if it produced all of the sedimentary rock, then we as Christians have to believe that the craters were made during the flood, because the craters are filled with sedimentary rock. They're made in the sedimentary rock, and then they're filled with more sedimentary rock, and then there's craters above that. And so as it went around the Earth, three, perhaps 4 times, but I think three and a half passes, as it went around, then I would say we had these rings of craters around the Earth, and they would be filled up as the bolides, these objects hit the Earth. The bolides, bolide is a Greek word for something that was thrown or cast or thrust. And it would be like meteorites or meteors, and as they hit the Earth. Now, some of these, probably a number of them were actually probably just large chunks of ice or maybe rocks in them. And so they come in at very high rates of speed and they're very, very cold. And we've already talked about these. We've had an extensive discussion of these. These bolides, mostly ice, were depositing the glaciers when the rain found the deep or tidal activity were all occurring. All of this was going on at the same time. Now, I want to read a fairly lengthy discussion here. All hypotheses are suspect until predictions based on those hypotheses are made and tested. Well, that's true. So my flood model is somewhat of a hypothesis, but we are basing it upon what the scriptures say, and then what we learn from facts of nature, and then we have followed up with proven laws of science, or pretty well established laws of science. There are unique criteria for recognition of shock metamorphism produced in minerals beneath impact sites. So when something comes in at high rates of speed and hits a rock, you can see there is a deformation of the rock and the materials in the rock due to that sudden shock that it has. I'm not talking electrical shock, I'm talking mechanical shock. It hits it real hard. And so the structure, you can take something and hit it with a hammer, for example, a piece of wood, and you can see it dented. So there's an impression made in the wood. Well, the same thing happens in rocks and minerals as they are impacted with objects coming at high rates of speed with a lot of kinetic energy. There's no criteria, however, which are as unique to glaciation or tectonism as shock metamorphism is to impact, that are available to test the hypothesis of glacial or tectonic origin of each tellite diamactite deposit. Now, tellites is like the gravel-like pieces of rock that have been broken off supposedly by the moving glacier. And again, I think glaciers do produce tellite, but some of these tellite, these pieces of gravel-like rock, have evidence of shock metamorphism. Something has hit them real hard, and so tellite diamactites may not be as reliably tested for glacial or tectonic origin as for impact origin. So Young's suspicion, now this is Overbeck, together with our reply, should now prompt the search for predicted impact shock metamorphism in the tellite diamactites, that this may permit the possibility to open a new fruitful area of research, which Young acknowledges can be sometimes the result from radical departures from conventional wisdom. See, he has called Overbeck's position a radical departure from conventional wisdom. In other words, we haven't thought that way before, and it's radical that he would introduce this, something new. And so that's kind of the way of expressing it. You read what Young wrote. And Overbeck just kind of turned it back on him and he had it back. But here he's saying we need to follow this up and look at it more carefully. And that's good science, to look at it more carefully. But of course, my flood model would provide for this shock metamorphism. And the metamorphic, that's the interchange of the rock itself, usually due to heat. Could be heat and pressure, both. Both of these change the rock from one form to another. This is possible. This is a possible explanation of some problem associated with this, but my flood model and my discussion that I had earlier of rocks fragmenting when impacted by cosmic ice, the presence of glacial till in early lessons. Remember, one of the things that drove the people away, geologists away from believing in the flood, and a couple of hundred years ago was they discovered glaciers and rocks formed by glaciers. So the flood models back then didn't have anything about glaciers in them. And so they began to modify and went away from the flood model because it didn't explain it. And my flood model does explain these, of course. We'll not venture further in this area because the research in this question is just beginning, and I haven't followed up with to see what research has been done since then, about years. It needs to be considered more fully and more thoroughly. And if I had remained a college professor, I probably would have been able to follow it up. But I didn't, and so things have changed. If the additional research recommended by Overbeck et al. Is conducted or has been conducted, perhaps there'll be more information. Now I'm going to quote Rehwinkel. He's an atheist. He's dead. He wrote this some time ago, but he made some very interesting thoughts, and I believe they're very good. So I'm quoting a theist. I'm admitting that. I'm a guy that believed in God of the Bible. He makes a claim that should be considered in great detail before one accepts the claims of the atheistic geology, uniformitarian geology, even infrequent catastrophic geology. Here's what he writes, and I want you to listen to this. This is very important. As soon as any mass of rock, whether igneous or stratified, so igneous would be produced by heat or pressure and heat, is lifted beyond the surface of water, as, for example, the strata which form the present continents on the world, they immediately become subject to the great forces of erosion, such as rain, frost, wind, and action of rivers, lakes, earthquakes, volcanoes, and so forth. All of these erosion processes set in, and we can see erosion occurring. Just water running on streams cuts through solid rock, and it does that, and it moves things around, and it will cut through very hard rock. And of course, then there's erosion due to frost, freezing, and cracks in the rocks, and the water gets in the cracks. And whenever water freezes, it expands and it pushes it apart. It has tremendous force, and it cracks the rocks even further. And this happens. This is some of the things we're talking about here. And of course, wind moves sand or particles across rocks, and it grinds upon them and changes the shapes of them there. Earthquakes crack rocks, and volcanoes create rocks. So all of this occurs, and it changes what the rocks look like and the surface of the land look like. One should therefore reasonably expect, this man says, we go back and get his name again, Rehwinkel, Rehwinkel. As soon as it occurs here, he says, one should therefore reasonably expect that the rocks exposed to these eroding forces for millions of years, as we're told the Earth is millions and hundreds of millions and billions of years old, ought to show evidence of such erosion on the surface. Now, we've already shown that the present rate of erosion of the continents should have, in 20 million years, should have brought them down to sea level, and it hasn't, because they're not 20 million years old. The erosion is so fast that all of it would be worn down to sea level in less than 20 million years. And we have two sites, two different atheists, pretty reliable people that claim this. And yet we don't see them eroded to sea level. So the continents are less than 10, 20 million years old, quite a lot less than that, just by virtue of the lack of the erosion. So now what happens, what are we seeing on the rocks we have now? We're seeing canyons cut in the rock by running water. I have seen canyons that are very deep. I've seen the Grand Canyon, I've seen other canyons that are very deep. I've seen places just where I grew up on my father's ranch. We have canyons that would be 30 or 40 feet deep. It's just got the water has got through the rock, and we should expect to find that these would be all over the land. But what we find is that the strata, older strata, should have these canyons, and they should be mutilated with places where the erosion's got through it. And what do we find? We don't find this. We find a layer of rock with no canyons in it for erosion. Then another layer of rock on top of that. And he said we should expect to find these older strata, and I'll read what he wrote now, mutilated and cut into irregularity symmetry even greater than those found on the surface of the earth today, because it's millions of years older. We ought to expect to find deep canyons, basins, hills, rugged canyons, and the like. But the strange thing is that such evidence is totally lacking. We don't find it. There's nothing in this kind to mark such erosion. We should see it, and it's not there. Marks of any disturbance of this nature are wholly absent from the time of the contact between the strata supposedly so vastly different in age. Obviously, it's not that different in age. The age difference, and that's pretty obvious. In fact, the younger strata follow the older in perfect conformity, and they appear as though one had followed the other in natural or uninterrupted succession. Rewinkle makes this point, and it has not been answered. I have his book, and it's a good book. Men like him did a great service, and they wrote some good material and did some good thinking. And I'm just trying to stand on their shoulders if I can with what I've written. There are other great men that have written things. As far as I can determine, Rewinkle is correct in his assessment of the nature of geologic formations. There are some exceptions, and there are places where canyons are cut, but my flood model postulated would allow for the existence of erosion in these strata, because a tidal flood would flow in and out and could cut canyons, so that they could occur, and they could erode mountains as the floodwaters moved around over the earth. Now, the early mountains that were created could be eroded very, very highly due to that erosion due to the flood. This would occur because of successive tides would overflow and virtually flow off the continent before the next tide, moving around upon the surface. But it'd probably be the exception rather than the rule. We find whole places where they don't have these canyons cut through. We don't have this. Just don't have it. The atheistic model is either uniformitarianism, with slow changes over billions of years, or infrequent catastrophes occurring, demand that this erosion be the general rule, because there have been long periods of time when they just had rainfall and other things that should have been eroding the rocks. If the atheists were to point out that Rewinkle is a theist, which they might want to, it doesn't prove that his points are wrong. They haven't answered it. That's not an answer. They need to answer his arguments. And his arguments, I believe, stand. Additional research should be done on the effects of large tides. Now, I'm listening to this, people that are so scared about global warming, they're saying the oceans are rising and it's going to kill some of the marine organisms. But I remember when I was very young, I thought a coral was a plant. Well, it's an animal, okay? But large tides are demanded, and they claim that as the ocean rises, some of the coral will die because it'll be too deep in the ocean to be able to survive. Some coral has to be in shallow ocean and some coral in a deeper ocean. And the deeper ocean, if it gets too deep, it'll die. Gets too shallow, they'll die. So these coral survive at a certain depth. But what we find is if the moon, we project backwards, the moon is moving away from the earth, And it's simple elementary physics. It's a transfer of angular momentum. If you've ever watched an ice skater, and every 4 years you can watch them and you can see them spinning, they'll start spinning, they'll move their arms in and they'll move faster, and then they move their arms out and slow down. And that's simple physics, change of angular momentum. And what's happening is the moon is moving away from the Earth. And we know how fast it's moving away from the Earth. If we project backwards with good physics, very, very well understood physics, we can say if we go back a billion years back in time, the moon will be very, very close to the Earth. And of course, it would move out away from the Earth, but it would create very large tides, and these tides would be extremely large. And of course, they would rise several hundred feet, several thousand feet every day up and down. That would kill all of the coral. Coral would die, and a lot of other things. And of course, the water would go over the land and kill any of the land plants and land animals. And so that would make things considerably different than they are now. We discussed this in lessons, but the effects of large tides on the land masses should also be considered. And of course, it would kill the corals. And again, you could just type in Google the effects of the rising ocean on corals and get articles on this. Large tides demanded by the old Earth model would kill certain corals. Here's, again, as I pointed out, corals live near the surface, others live deeper. Fairbanks states that Caribbean reef crest coral, Acropora Lomric. Lomric is the one fellow that's classified, I believe, the plants and so forth. Acros is probably from the Greek word acros, the top of, and that's a Greek preposition for Acropolis, is the top of the city, Acropolis, is the best available sea level indicator for Pleistocene studies. So what they say is we look at this coral and we can get how deep the sea level was, because this coral can't survive below a certain depth or above a certain depth. And so they look at this coral and they get this coral to see what the sea level was. And it's probably good. It's probably a good measure of it. This species is generally restricted to the upper 5 meters of water and dominates the reef crest community in many locations. So now, of course, the word meter is spelled it's a British spelling, M-E-T-R-E. M-E-T-E-R for American spelling. Same word, though. It's just a meter. 39.37 inches if you want English terms or American terms. So, yes, about 5 meters of water. So, if the water, however, got deeper than this coral dies, 10 or 15 meters deep, it'll die. And if it gets too shallow, if it gets out of the water, it dies too, because it has to have water. So if it gets above the water level, then the coral will die. These large tides that would occur as the moon gets closer to the Earth would cause the coral to be above the sea level for several hours every day and deeper than normal, than it can normally survive at other times. It wouldn't live, it wouldn't survive. And so if we project backwards very far, we can't get back and have the coral live. But they claim the coral's been around for hundreds of millions of years. But again, they get into the trouble with the moon being too close and causing too high tides. But I have no problem if I have a young Earth. It doesn't affect my position. Additional research should be done on the effects of different wavelengths of sunlight on various life forms to be considered in light of the flood model set forth in this class. It's postulated that the water vapor canopy, the waters above the firmament, Genesis 1, 6 or 8, we'll look at that very quickly, would prevent harmful wavelengths from reaching the surface of the Earth and would allow the best combination of wavelengths for the health and well-being of all living organisms. That's my hypothesis. I postulate that. And I claim that this would be the case because God set it up that way. And so harmful wavelengths will not be able to penetrate through the water vapor and living organisms, plants, and animals will be protected. Genesis 1:6-8 talks about the waters above the firmament. And I believe this was the water vapor canopy, as we've already laid out. We won't look at that. Ultraviolet light, upon eyesight, plant growth need to be explored. Ultraviolet is a sterilizing light. It'll kill bacteria and other things, and it's very damaging to us. It can create other problems like sunburn and other problems that probably causes skin cancer. To get too much ultraviolet light of a different wavelength, short wavelength. In addition, if organisms evolve by macroevolution in an environment with ultraviolet light present, it's in order to ask the question, well, why is ultraviolet light harmful to these organisms? Why didn't they adapt to it? And so that would be a good question. Why? Surely some of these organisms would have adapted by macroevolution to the ultraviolet light, but we don't have them adapted to it. Additional research, but if they were created by God to optimize the antediluvian atmosphere where there was virtually no ultraviolet light to be a problem, then we can see why they would not be adapted to it. And additional research should be conducted on the effects of the spectrum of light on water vapor canopy would pass through. What kind of light would pass through it? And human eyesight, according to sulfur, doesn't optimize the present light spectrum. And so we don't optimize the light. Sulfur says many people believe that evolution has produced a human eye whose color sensitivity roughly matches the sunlight spectrum. The eye is poorly optimized to take full advantage of all the visible and enormous amount of infrared light. Infrared is heat, and it's a lower energy level and a longer wavelength than the lowest, the red light that we see in the normal spectrum. The Roy GBF spectrum, red, orange, yellow, blue, indigo, violet range. And red is the longest wavelength, the lowest energy level. So the infrared light, our eyes don't optimize and don't use it. There's a lot of it in the atmosphere and the environment. He argues, of course, he's an evolutionist. He argues that the vertebrae eye, and of course that's an animal with backbone like we have, optimizes the solar spectrum after it's passed through water. So he claims now that's proof that, and of course he commits a logical fallacy. We'll show that in a moment. That's proof that they evolved from water animals, from marine or aquatic animals, based on the assumption that vertebrates evolved in an aquatic or marine environment. Actually, he might be partially right. Not that the evolution occurred, organic macroevolution, but if the antediluvian atmosphere contained large amounts of water vapor, it might optimize it after it had passed through water. And he might be right, part of his assumption. Here's his basic argument, however. His first premise is, if vertebrates evolved from marine aquatic organisms, then their eyesight will optimize light that has passed through water. Now, that's probably true if organic macroevolution occurred. I'll give him that point. If this happened, then they would have optimized light that passed through water. And their eyesight optimized light that passed through water. Now, that's probably true too, or appears to be. Now, what does that prove, though? He claims it proves vertebrates evolved from marine aquatic organisms. The problem with this whole argument is it contains a logical fallacy. He affirms the consequent rather than affirming the antecedent. So he affirms the consequent. And it contains that logical fallacy of affirming the consequent. And this is a common fallacy that atheists make. And they ought to be ashamed of themselves. They can't reason any better. And since it contains a logical fallacy of affirming the consequent, and I'll let you look that up when I want to teach a logic course, hopefully starting in about 4 or 5 months. We'll start in 3 or 4 months, hopefully in January of next year. But since this argument contains that fallacy, it's invalid. Invalid argument, logically invalid, means it's not constructed by the rules of logic. And if it's invalid, it's not sound. Sound means if it's sound, it proves its case. It has to be valid and properly constructed, and it has to have truth in its premises. Well, it's invalid, so it's not sound. It doesn't prove anything. I guess it proves one thing. It proves this man doesn't know how to argue properly, reason right. But other than that, it really doesn't prove anything about what he's trying to prove. It proves nothing for us. The human eye probably optimized the antediluvian environment, and so the light had probably passed through a water vapor canopy. And so it would look like it optimized the water. Now, we should look at, I believe this will be my last point, we should conduct research on the reason or reasons why bristlecone pine trees going to be found living that are over about 4,600 years old. So there are trees living. There's one in the western United States called the Methuselah tree, and they found one that's even older than it now. But the government is not telling anybody where those trees are. And I hope they don't, because there's some idiots out there that go out there and just kill it. Just say, I killed a 4,000-year-old tree. Bunch of idiots. But there are people like that. But Ralph and Michael state living bristlecone pines have reached the age of about 4,600 years. That is, their innermost rings date to about 2,600 BC. This is approximately the date, pretty close to it, that I give for the flood, about 2,600 BC. Right? Why are there no living trees older than this age? Now, think about it a minute. Trees don't die of old age. They're killed by fires, disease, insects, storms, or droughts, or too much rain, being flooded, drowned out, die that way. But they don't die of old age. So why do we not have any of those bristlecone pines that are older than that? Right? Summarize in the lesson will be yours. Many additional matters need to be researched. I'll have one more lesson like this, and to determine if they're in harmony with the Fox-Love model. I believe the things that I've set forth here, we can show that there's probable harmony with it. Remember that a good hypothesis will predict future matters and lead to new discoveries. That concludes our lesson.